according to experimental condition. You would have already created the files, which previously we called LabVIEW1 files, basically the files that had each individual walks indexed, the locations of each individual walks indexed, as well as the experimental conditions listed next to it. These files you would have created, and they typically look something like this. First column has the actual gate files, second column has the tempo, third column has the stimuli, and fourth column has the experimental condition. So you'd have created that for every single participant. After you've done that, you have to create a file that will contain the different experimental conditions in your study. So that will simply be read by the LabVIEW program. So in that example, you have an example file would look something like this. So this has all the experimental conditions listed. So I'll just save that as the sample conditions. So that this can be read. Again, LabVIEW tends to prefer to save text tab delimited files. So that's this one. So you have to save that. So that's sample conditions. Okay. Okay, now that that's created, then you can go ahead and run that file. Now that file, the executable file, which will sort the gate parameters according to the experimental condition. Okay, so to open the executable, you go into there and open basically this file, sort gate params according condition.exe. It will first ask you which folder you'd like to save your files into, and so let's just go ahead and create a new folder. And navigate into it and then select correct folder. Then you will be asked to get the conditions file which you created before. So I'm just going to select the conditions file which was corresponding to this data set that I'm now going to analyze. So that's this file. So again, it will look something like this. It will have the different experimental conditions listed in the very first column in different rows. So I'm just going to close that and select that file, hit OK. And then the next prompt will be, it will ask for get the file logs file, so file locations file, which was previously known as all these LabVIEW1 files. So these files, again, if you go ahead and open them outside, you can see that they have the absolute file paths of the individual gate files. So if you go ahead and open that up, you can see that they actually contain all the gate parameters. So this will only work if you've already converted the files from Unicode to ASCII, which you would have done in a previous video. So what you're going to do now is select those two files for these two participants. And then it will ask you which gate parameters are you interested in analyzing now. So now I'm interested in analyzing step length. So I'm just going to type in number 13. And then it will come up with a last prompt. It will ask you which column contains your experimental conditions in the LabVIEW1 files, or the file logs files, those files that you created just now, that has for every participant the different conditions. So in this case here, it would be the conditions are listed in column D. Now in programming languages, typically you start counting from 0. So this is column 0, column 1, column 2, column 3. So you actually type in column 3, okay? And it will do that automatically. And to go to the output file, you simply go to this box here that's type that's labeled which folder are the files saved to. So you go there, hit Ctrl+C to copy the file path, paste that to a Windows browser, and that is the output files. So if you open them up, what they contain is individual files that contain each experimental condition. So in this case, there were 10 experimental conditions, therefore 10 individual files. And if you open that file up, I'll just open that properly. Each row corresponds to the stride by stride, what parameter do we look at? Stride by stride step length. Step by step length. And column B is the participant. So here we analyze 2 participant data, so that's step by step length for participant number 1 and number 2. The third column, column C, contains the stimuli, and we had participants go through 2 different stimuli for one condition. So that's why we have 99 primavera.wave for participant number 1, and 99 BG music .wave for participant number 1 under the same condition. Okay, so to analyze this data quickly, what you do is you use pivot tables. Before you do that, you should remove all these erroneous zeros that are simply created when LabVIEW reads an empty cell from the G file. So to do that, what you do is you would replace the values. You would select the entire column A, press Ctrl F simultaneously, say you'd like to replace all cells that have the whole cell as 0. So you don't want to replace these zeros here. You want to replace instances where the whole cell is 0. So match entire cell contents. Replace that with, I like to use not a number because it's safer, I find. But you can also just replace it with nothing. So that's just replaced. That's just deleted. So that's done. If you like to clean up all those not a numbers as well, you can do that. Now that's cleaned, what you can do is go ahead and label these columns. So hit Insert, and then label the columns. So here we have step length, participant, song, and condition. Now you can go ahead and create a pivot table. So hit Insert, Pivot Table, and select columns A to D. Columns A to D. In this case, it only looks like there's a column E here that's filled, but really it's just column A to D. And what you can do is make the pivot table, get the pivot table to be placed in here. I like to create it in the same sheet because it's clearer, but you might have different preferences. If you want to create it in a different worksheet, you can. So that now allows you to enter the values in to the pivot table. So here I like to label each row as the participant number. So I want to find out the mean values for every participant. So what I'll do is I'll label the rows according to participant number, and then I'll like to see this average step length for each participant. So the default, quite frustratingly, that pivot tables give you are the count, how many cells were there. So we know that for S001 there were 167 cells and 167 steps. So we don't want that. We would like the average value instead. So hit average, and that will have these 2 values here. So that will quickly and efficiently give you the average values. You can also get it to appear again and so do the same thing again, but now instead get the standard deviations. So those are the standard deviations for this participant under this experimental condition. So that's it.